All right, let's just dive right in. Today in this explainer, we're unpacking a really fascinating statistical physics paper. It's by a team of researchers, Pluchino, Biondo, and Rapisarda, and they use mathematical modeling to investigate something I think we've all wondered about at some point. What is the actual mathematical relationship between natural talent and extreme wealth? We are taking a hard, data-driven look at the meritocracy myth.
Think about this glaring real-world paradox for a second. We all know human abilities, things like height, physical speed, or, even intelligence. They have hard biological limits, right? The smartest person alive isn't a billion times smarter than your average Joe. The hardest worker out there definitely doesn't work a billion times more hours than you or I do. But when you look at financial success, poof, those limits completely vanish.
To really wrap our heads around this, we've got to contrast human traits with the math of global wealth. Human traits generally follow what we call a normal distribution, a bell curve. Take IQ scores, for instance. They cluster right around 100. Literally no one on Earth is walking around with an IQ of 10,000. But wealth? Wealth plays by entirely different rules. It follows a mathematical power law. We live in a world where just 8 individuals own the exact same amount of wealth as the poorest 3.6 billion people on the planet. So how on earth do normally distributed human traits create such an insanely skewed outcome?
Which brings us to Section 1, the meritocracy paradox.
To solve this paradox, we kind of have to treat it like a crime scene. We're looking for that hidden ingredient, the invisible force that takes normal, everyday talent and transforms it into extreme wealth. So these researchers built a computer simulation, and in their virtual world, they gave every simulated agent a talent score. Now, talent here is a catch-all. It means intelligence, skill, hard work, the whole shebang. And just like in reality, this talent is on a bell curve. It peaks right in the middle at an average score of 0.6. So most folks are totally average, a handful are relatively unskilled, and a tiny fraction are absolute geniuses.
Let's move to Section 2, Building a Success Simulation.
They called this the Talent versus Luck model, or TVL. Basically, it's a 40-year simulation of a human working life, running from age 20 up to age 60. The whole point here is to strip away all our real-world biases, let the math run wild, and isolate exactly what makes someone a winner. Here are the rules of the game. First, we drop 1,000 agents into the simulation. Everyone, and I mean everyone, starts with the exact same capital, 10 units. No trust funds here, no unfair disadvantages, just an even playing field. Over the next 40 years, 2 types of random events bounce around. Green dots, those are lucky breaks. If a green dot hits you, your wealth doubles. But, and this is crucial, only if your personal talent score is high enough to actually exploit that opportunity. On the flip side, we have red dots, unlucky events, a market crash, a random illness. If a red dot hits you, your wealth gets slashed in half, completely regardless of how smart or talented you are. Bad luck simply hurts everyone equally.
If you picture this simulation grid, the black figures are our agents. They're fixed in their spots, sitting there with their hitting bell curve talent scores. And swarming all around them are these red and green dots, bouncing off the walls on totally random trajectories. The agents are just living out their 40-year virtual lives, basically waiting to see if a streak of good or bad luck is going to cross their path.
And that brings us to Section 3, the shocking results.
So what actually happens after 4 decades of green and red dots smashing into our agents? Well, the results were stunning. They perfectly recreated the extreme wealth inequality we see in our actual society. Remember, everyone started with the exact same 10 units of capital. Talent was perfectly evenly distributed on a bell curve, yet a massive wealth gap exploded anyway. That classic Pareto 80-20 rule just naturally emerged right out of the math. The top 20% of the most successful individuals ended up hoarding 44% of the total capital, while the vast majority of everyone else just languished near the bottom.
Okay, so here is the million-dollar question. Literally, were the richest agents simply the most talented? Did the whole meritocracy ideal actually hold up? In a perfectly fair simulation where the smartest people absolutely have the best odds of capitalizing on good luck, did the geniuses secure the most wealth?
The answer is a massive, resounding no. No way. The absolute wealthiest agent in the entire 40-year simulation, the one who totally dominated this virtual economy, had a talent score of exactly 0.61. Now, remember, the absolute dead average talent score was 0.60. So the ultimate billionaire of this world was just a completely, thoroughly average person.
Well, what about the smartest person in the room? The agent with the highest talent score of all, a whopping 0.89. The true, bona fide genius of the simulation. You know where they ended up? with a final capital of less than 1. Yeah, less than 1. Their starting capital of 10 wasn't just stagnant, it was utterly wiped out. The genius was a complete financial failure, while the incredibly average guy essentially became a titan of industry.
Let's dig into Section 4, Why Average Beats Genius.
If we look under the hood of the simulation data, we can actually see the exact mechanics of how this happened. How did an exceptionally average person mathematically destroy a once-in-a-generation genius? It's basically a tale of two agents. On one hand, we have our incredibly average winner. If you trace their timeline, they caught this massive exponential streak of green lucky dots right near the end of their career, which just totally catapulted their wealth into the stratosphere. On the flip side, we have our genius, and despite having the absolute maximum ability to capitalize on good luck, they were just endlessly battered by a relentless streak of red dots. Misfortune simply chipped away at their capital, and frankly, no amount of talent could save them from the brutal math of consecutive bad luck.
So, what's the big takeaway here? It's really about understanding the difference between the micro view and the macro view. At the micro level, like for you as an individual walking around in the world, having high talent absolutely increases your odds of success, no question. It lets you grab onto opportunities. But at the macro level, when we zoom out to the whole society, the sheer volume of averagely talented people dictates the outcome. Because there are literally thousands of average people for every single genius, the statistical reality is that the person who catches the absolute most insane streak of luck will almost always be pulled from that massive pool of average people.
Which brings us to our final section. Section 5. Rethinking how we reward.
If extreme success is mostly just an exponential streak of luck, we really need to zoom out and ask how this impacts our actual society, especially how we hand out money, resources, and honors. The researchers issue this really stark warning against what they call naive meritocracy. They put it perfectly. Rating as the most talented people those who are simply the luckiest ends up switching cause and effect. We all suffer from hindsight bias. We see a billionaire or a heavily awarded scientist, and we just automatically assume, wow, their extreme wealth is undeniable proof of extreme competence. But this study pretty much proves that is a mathematical fallacy.
And that hindsight bias creates massive systemic flaws in how we fund innovation today. Think about it. Right now, society loves to hand out huge grants, venture capital, and prestige mostly to past winners. This triggers something called the Matthew effect. Basically, the rich get richer simply because they're already rich. The researchers point out that dumping all our funding onto a few lucky individuals actually creates diminishing returns. It's incredibly inefficient from a statistical standpoint. And honestly, the worst part? It actively excludes genuinely brilliant, talented people who just haven't caught their green dot yet.
So how do we fix it? What is the mathematical solution here? Well, the simulation data strongly suggests that society as a whole actually progresses much faster when we spread our resources out. Instead of handing massive grants to a few quote-unquote proven winners, who, let's face it, were probably just really lucky, we should be distributing smaller grants to a much larger pool of people. We should be targeting a wide diversification of ideas. By doing that, you actually increase the surface area for lucky events across the entire population. You're casting a much wider net, giving genuinely talented people everywhere a real opportunity to finally catch a green dot and push society forward.
I want to leave you with one final thought to chew on. If this data truly holds up, if immense, extreme success is statistically proven to be mostly a product of wild luck rather than just pure merit and grit, how should that change the way we view poverty? Or more importantly, how should it change the way we treat the unlucky? It's a pretty profound question, and honestly, it challenges the very core of how we judge human worth. Thanks so much for joining me for this explainer, and as always, keep questioning the systems around you.